folks, let's see if we can't find that difference quotient. So we're being asked to compute and simplify a difference quotient, and our function is a fraction. So what that means for us at some point is we're going to be adding and subtracting fractions. We're going to need common denominators. It's going to get pretty messy. Typically, when you have fractions and you're being asked to find a difference quotient, you're going to need some kind of common denominator. If this was just a straight polynomial, we'd probably just do we would probably do a bunch of canceling. If this was a radical, we'd multiply by a conjugate. Those are pretty common, quote unquote, things that you do when finding a difference quotient, but we've got the fraction, so we're going to be finding some common denominators. So let me start by finding f of x plus h. So we always need f of x plus h whenever you're finding a difference quotient. So that would mean instead of writing an x here, I would write an x plus h. But because this is a binomial, I need to protect it with parentheses. So this would be 1 minus 6 minus, in parentheses, x plus h. And when I distribute that negative a little, it's 6 minus x minus h. Okay, so keeping that in mind, let's go find this difference quotient. All right, so I'm going to start with my original expression. Pretty standard, f of x plus h minus f of x over h. And you'll see this a ton in calculus. All right, so let me go ahead, substitute in my particular function. So f of x plus h is 1 over 6 minus x minus h. The original function is 1 over 6 minus x, and this is all just over h, okay? All right, so I've got two fractions. Ooh, that came out messy. Let me see if my fancy eraser will get rid of it. Not really. Oh, well, we'll just leave it there. I don't know how much you can actually see that smudge by the time it shows up on the video. Okay, I want to add these fractions, but I'm going to need common denominators. So if I want to think about my least common denominator, it's going to be these two denominators multiplied together. So we're going to go 6 minus x minus h times 6 minus x. All right, and I'm going to just multiply each fraction by a special version of 1, namely what they're missing from this LCD. So I don't think I can squeeze all of that in one line. I'm going to go to the next line. This gets pretty crowded pretty fast. I'm going to take my first fraction, and if I look at this denominator in comparison to my common denominator, it's missing a factor of 6 minus x. So I'm going to multiply top and bottom by 6 minus x over 6 minus x. So I'm going to take my first fraction of 1 minus 6 minus x minus h multiplied by 6 minus x over 6 minus x, okay? I'm going to take a look at this fraction. This denominator, if I look at my LCD, my common denominator, it's missing this factor of 6 minus x minus h. So I'm going to multiply this fraction by 6 minus x minus h over 6 minus x minus h. So I have 1 minus 6 minus x times 6 minus x minus h, 6 minus x minus h, right? I'm going to put parentheses around all of this, but you can start to see, right? If I put parentheses around these denominators, I'm now looking at, I'm going to have common denominators, and that's what you need to add and subtract fractions. So let me just clean this up a bit. I'm writing pretty small because there is so much algebra involved. So we have 6 minus x here, and then we have 6 minus x minus h, 6 minus x minus, okay, this is going to be 6 minus x minus h here, and then we have 6 minus x minus h, 6 minus x. So, oops, let me not forget this divided by h thing here. Now, because these are common denominators, I can just subtract the numerators. The thing we got to be careful about is this negatives or this subtraction symbol. I've got to subtract this whole trinomial, and I'm going to need to protect that with parentheses, right? So here we go. So I'm going to combine numerators. So on this, I'm going to write, here's my fraction bar. We've got the h. I'm going to combine these two fractions with the common denominator, 6 minus x minus h, 6 minus x. All right, so we've got up here 6 minus x minus 6 minus x minus h. Okay, and let me just simplify this fraction bar, or not simplify, but just give myself some space to write. I'm going to distribute this negative, and we're going to see what starts to cancel out. So if I look at this, right, this looks like this is on the numerator 6 minus x, all right, minus 6 plus x plus h all over, and I'm going to have 6 minus x minus h, 6 minus x. Now I could write here divide h, right? But I'm just going to write it this way so we can start to see the algebra involved, okay? Because when I divide by h, in a moment, oops, on my next step, I'm going to say this is going to be me multiplying by 1 over h, multiplying by a reciprocal, okay? Now, we can see some things are going to start to cancel. The 6's are going to cancel, and they should. That's a good sign. The x's are also going to cancel, and that's just going to leave me with an h up here. So this is going to be h over, what do we have? 6 minus x minus h. 6 minus x times 1 over h. And then you can start to see these h's are going to cancel. And when I start to finally clean this up, I know it's a lot of algebra. I have 6 minus x minus h down here and 6 minus x. Let me make that look a little bit more like an h. All right, now let me head over to my answers and see what we've got here. So first of all, I can rule out every answer but A because my numerator needs to be 1. So this is not it. And let me just check that my denominator 6 minus x minus h, 6 minus x, that does line up with what I have. So A will ultimately be my answer. And that is a lot of algebra, all right? So thank you for hanging with me. I appreciate you.